Welcome. Today in this session we are going to discuss about minimization of finite automata by My-hil Nerode theorem. This is the algorithm to My-hil Nerode theorem. In step 1 we are going to draw a table for all the pairs given in the finite automata. In step 2 we are going to mark all the pairs based upon this condition where P belongs to F and Q does not belongs to F. P and Q are nothing but the states in the finite automata. In step 3, we need to mark all the unmarked pairs from the table which we have obtained in step 2. So, here we need to consider this condition such that delta of P comma X. P is nothing but the state, X is nothing but the input symbol. So, whatever the input symbols given in the finite automata, for each input symbol we have to find out the output, and that pair, if that pair is marked in the table of step 2, then we should mark it in the step 3 also. If it is unmarked in step 2, then leave as it is. So, in this manner we need to mark and unmark all the cells in the table. And in step 4 we are going to combine all the unmarked states and we are going to consider draw the transition diagram. This is the procedure which we need to follow. Let us see this by solving an example. This is the example. For this example, we need to obtain the minimized finite automata. If we observe in the diagram, A is the initial state, C, D, E are nothing but the final states. So, we need to consider the condition which we have seen in the step 2 and mark the cells in the table. Before doing that, let us construct a transition table. This is the transition table which we need to construct by seeing the diagram. So, construction of transition table is very easy. So, let us construct it. Here, the states in the figure are A, B, C, D, E, F. So, let us take all the states and the input symbols are 0 and 1. For the input symbol 0 and 1, we are going to find out the transition function for each and every state. So, starting from the initial state, A by reading the input symbol 0, it goes to the state B. And A by reading the input symbol 1, it is going to the state C. B by reading the input symbol 0, coming to the state A, and B by reading the input symbol 1 moving to the state D. C by reading the input symbol 0 moving to the state E. C by reading the input symbol 1 moving to the state F. In this manner, we need to construct the transition table for all the states given in the diagram. So, let us consider step by step. So, in step 1, draw a table for all the pairs P, Q. So, for all the pairs in the sense, all the states we need to consider given in the diagram. So, let us see. See, we need to draw the table in this manner. A, B, C, D, E, F are nothing but the states in the question given. So, we need to draw the table. So, we need to keep all the states horizontal wise and vertical wise and divide into cells. Here, AA will become a pair, AB will become a pair, AC will become a pair, AD, AE, AF will become a pair. In such manner, so each and every cell is nothing but a pair formed with two states. Now, as per the step 1, we have constructed a table for all the pairs. In step 2, mark all the pairs. So, before marking all the pairs, we need to divide this table. So, how to divide the table? Here, if we observe, the cells A and A are repeating. That means A is repeating. Similarly, B is repeating. C is repeating. So, first shade all the repeated states. D is repeating. So, shade that repeated cell. E is repeating. So, shade in this manner. F. And now we need to divide the table into two halves. We need to remove the upper part of the diagonal. So this is the diagonal and we need to eliminate the upper part of the diagonal, because this upper part we are removing in the sense these cells are again and again repeating. So if we consider just one pair, it is enough. In this manner, the upper part will be removed. So after removing the upper part, the table looks like this, which is drawn in this step 2. Now we need to mark all the cells based upon the condition which we have seen in this step 2. Mark all the pairs where P belongs to F and Q does not belongs to F. If we observe in the diagram, so what is the F final states? C, D, E are the final states. Now if we observe A and B is one pair, so we need to check A and B is one pair. We need to check B. Does B belongs to the final state? No. And A. Does A belongs to the final state? No. That means A does not belongs to the final state and B does not belongs to the final state. So this condition becomes false. What is the condition we need to consider? One should belong to the final state and the other should belong to the does not belongs to the final state. If this is true, then only we have to mark. But if we observe here, A and B does not belongs to the final state. So leave that state. Don't mark it. So if we observe, we should not mark this state. Coming to the pair C and A. For the states C and A, if we observe, here C belongs to the final state and A does not belongs to the final state. So C belongs to the final state and A does not belongs to the final state. So this condition is true. Now mark it. So now mark it. Similarly, if we observe C and B. So C belongs to the final state and B does not belongs to the final state. So mark it. Coming to D. D belongs to the final state. A does not belongs to the final state. So mark it. D belongs to final state and B does not belongs to final state. Mark it. D belongs to final state. C also belongs to final state. So don't mark it. E belongs to the final state and A does not belongs to the final state. Mark it. E belongs to the final state. B does not belongs to the final state. Mark it. E belongs to the final state. C also belongs to the final state. Don't mark it. E belongs to the final state. D does not belongs to the D also belongs to the final state. So don't mark it. Next, F. What is F in the diagram? If we observe, see, F is not a final state and A is also not a final state. Don't mark it. F is not a final state. B is not a final state. Don't mark it. F is a final state. F is not a final state and C is a final state. Mark it. F is not a final state. D is a final state. Mark it. F is not a final state. E is a final state. Mark it. So in this manner, as per the algorithm, we processed second step. Now we are going for the third step. In third step, we need to concentrate on the unmarked cells. So what are the unmarked cells? AB, next DC, next EC, next ED, FA, FB. So we need to concentrate on this unmarked cells. So let us start with the states AB. So if we start with the states AB, we need to find the transition functions. So delta of A comma 0. So we need to find the transition functions with both the input symbols, input symbol 0 and input symbol 1. Delta of A comma 0, we get B. We have to look into the transition table or the diagram. So if we observe here in the diagram or transition table, delta of a comma 0, the answer is B. Delta of b comma 0, the answer is A. Delta of a comma 1, the answer is C. Delta of b comma 1, the answer is D. So we need to check whether the pair AB is marked in the table or not. So if we observe here, is the pair A comma B marked in the table? No, it is not marked. A and B are not marked. So check the pair C and D. Is C and D marked in the table? For the input symbol 0, A and B is not marked in the table present in the step 2. Now we have to check for the input symbol 1 output C and D. So is C and D or D and C marked in the table in step 2? No, it is not marked. So when these output pairs are not marked, we should not mark the pair A comma B, because we have worked out on the pair A comma B states. So we should not mark the pair A comma B in the table. So this cell will remain unmarked. Now coming to the pair D comma C. Coming to the pair D comma C or C comma D. Now find the transition function delta of C comma 0, delta of D comma 0. Similarly, delta of C comma 1, delta of D comma 1. So delta of C comma 0, if you observe here in the transition table, delta of C comma 0 is E. Delta of C comma 1 is F. Delta of D comma 0 is E. Delta of D comma 1 is F. If we observe, do we have the pair E comma E in here? Do we have the pair E comma E here in the table? See, if we observe, do we have E comma E? No. Do we have F comma F? No. As we don't have E comma E and F comma E, then this CD will remain unmarked. So the pair of states CD will remain unmarked. So don't mark CD here. Now coming to the pair E and C. Coming to the pair E and C. So if we observe, coming to the pair E and C, delta of E comma 0 is E, delta of C comma 0 is E, delta of E comma 1 is F, delta of C comma 1 is F. If we observe the outputs, we don't have the cell E comma E and F comma F. So there is nothing to be marked. So EC will also remain unmarked. EC will also remain unmarked. Now coming to the pair E and D. So coming to the pair E and D, find out the transition function delta of E comma 0, delta of D comma 0, delta of E comma 1, delta of D comma 1. Find out the outputs E and F we are going to get. We don't have the cells at all. So that means there is nothing to be marked for the pair E and D. Coming to the cells FA. So we left out ED also unmarked. Now coming to the cells F and A. For the states F and A pair. So FA pair, delta of F comma 0, delta of A comma 0, delta of F comma 1, delta of A comma 1. For the state F, under the input symbol 0, the output is F. A for the input symbol 0, the output is B. F for the input symbol 1, the output is F. A for the input symbol 1, the output is C. Now check for this pair BF or FB. So check BF. Do we have BF or FB? No, we don't have BF or FB. So leave it. Now check for this CF or FC. See here, the output for the 0 input symbol is FB. If we observe, we don't have any B F cell marked. So don't mark this. Coming to the input symbol 1, if we observe here F, C the output. If we observe here in the table in step 2, F and C. See, F and C. Here it is marked. So as this is marked, we need to mark this cell FA, because FC is the output for which pair? For the pair F and A under the input symbol 1. So we need to mark the pair FA. Already F and C is marked. As this is marked, we need to now mark the unmarked pair F and A. So just mark this. Now coming to the next unmarked cell is F and B. So F and B, delta of F comma 0 is F, delta of B comma 0 is A, delta of F comma 1 is F, delta of B comma 1 is D. Now see, check F0, B is 0, what is the output? FA. Now if we check F and A was recently ticked. So as this is ticked, we need to mark the pair F and B. That means F and B cell has to be marked. So in this manner, we have checked all the unmarked cells also. So we completed step 3. Now what is this step 4? Combine all the unmarked pairs and make them a single stage in the minimized DFA. So we are going to combine all the unmarked cells. So what are the unmarked cells here? If we observe here, A and B is unmarked. So A and B is written here. C and D is C, D and C. C and D is unmarked. So write here. Next, E and C. E and C is unmarked. Right here. So E and D is unmarked. Right here. If we observe here in this pair C and D is present, in this pair EC is present. So this C is already repeated, and again in this pair EC is present, this E is already repeated here, and this D is already present here. That means we are going to overlap all these 3 unmarked states. So we are going to combine all these unmarked states as they are getting overlapped. So AB will become one state here, CDE will become one state here, and what is the remaining state? F. Left out state is F. This will become the one state. In the given question, there were 6 states, but now we have minimized to 3 states. This is one state, this is one state, this is one. 1, 2, 3. 3 states. So this CDE is the final state even in the minimized finite automata, because the CDE was the final state in the given question also. So by seeing the question, by seeing the diagram given in the question, we are going to draw the transition lines. This is how we are going to obtain the minimized finite automata with the help of My-hil Nerode theorem. Thank you.